Right, so today we're going to deal with shearing stress of non-thin wall. Term test 2 is on a Monday. Okay, I repeat again. Term test 2 is on a Monday, 4th of March. Topics cover will be homework 3 and homework 4. Okay, so homework 4, I'll try to, homework 4 is not that straightforward, but it's not difficult also, okay? So you have to pay close attention to me regarding shearing stress. Okay, I'm aware that you have learned shearing stress before, but this is different. Okay, we go into more depth and more detail. Right. So this diagram was given to you before reading week. Okay, so what we are trying to do now is what we like to, we are going to really begin. Is it back? It's back. Okay. So what we're trying to derive, or what we're trying to show, is we are going to derive the expression where tau xy is equal to 3/2 Vy over A. Okay. And then we have 1 minus y squared over c squared. Okay. So what we see over here is, in this diagram over here, I want you to put a shear force, okay, coming over here. This is known as your Vy, okay. So probably you have forget most of the things that you have learned. There are a few things I'd like to clarify. So shear xy, it means that the shear stress acting on the plane intersecting the x-axis and the shear stress is along the y direction. Units over here can be Pascal or PSI, okay, pounds per square. Now, there's another expression, right, that equation number 1, which we are trying to derive from. So equation 1 is from equation number 2, where you have shear xy is equal to Vy over Izz Qz over T. Okay. And this is our equation number 2. And we have mentioned that Vy, as you can see from the diagram, is the shear force in the y direction, and Izz is the second moment of area about the ZZ axis. Now, in this topic, the most confusing part, okay, I'm going to put asterisk down here. You have to focus on this. Is your QZ. QZ define the first moment of area about the z-axis. Okay, first moment of area. And the formula is given, or the formula for first moment of area is QZ is equal to A y bar. And this is equation number 3. Okay. And the first moment of area, I do apologize, over here is Newton or pound force. Over here is meter to power 4 or inches to power 4. First moment of area is meter to power cube or inches to power of cube. Okay. So A over here, it means is the defined area. Units is in meters squared or inches squared. And Y bar is the distance between the global centroid to the centroid of the defined area. Okay. And P is the thickness of the defined area, okay, and is in meter or inches. And this thickness over here is important to note that the thickness orientation is perpendicular to the shear flow. Shear flow over here is known as Q. And Q is equal to VQ over I. Okay, this is our equation number 4. Now, we are, math is language, right? It is a language. When I was young, I was no good in math. I asked my sister math questions, and my sister is brighter than me, and she said, brother, math is a language. You know what I tell her? Read the page. But you know what? I'm the idiot. He's correct. Math is a language. We are going to derive the shear stress expression, and we are going to set up rules. To do this topic well, you have to comply to these rules. Mechanical engineers are really bad in following what? I'm just saying. Okay? I want you to focus on the rules. Okay? These rules are derived mathematically. We clear? Only if you follow all these rules, then you can do this. Okay? Are you surprised? Were you taught this in 2P or no? No, right? 2P, what do? You just put in the formula. Am I right? Okay? This is different. Why this is different is because you have to be able to plot the shear stress distributions. And the geometry is much more complex. Okay? But I can guarantee you this. You're going to have fun. Okay, I can guarantee you. Now, let's look at the first moment of area. Let's focus on the first moment of area over here. Okay, so I'm going to take this diagram, start a new page. Okay. Now you have this diagram. Okay, you need to. So the what you see over here, the gray region, this is the defined area. Okay. The y you see over here, this is your variable. So the y can either slide up or slide what? Down. Okay. So the first moment of area Q, okay, and Q is Z. Okay, this is QZ. QZ means what? The first moment of area is going to rotate about which axis? The Z-axis. The moment is going to be taken from the Z-axis. So the definition of moment is any value or the cross-sectional area multiplied by Y bar. Okay. Now, we are now going to come out with an expression. Okay. So as I say, Y is a variable. Okay. So what I would like to do is, I hope you will follow, is we're going to do width multiplied by depth multiplied by Y bar. Okay. So which is the width, right? This over here will be our width. And this over here will be our depth. Okay. Now, why is that? Okay. If we go back to the formula, shear xy, this is equal to Vy over what? Iy. Izz Qz divided by T. Okay. So Izz is the what? Is the axis of interest. I repeat again, the z-axis is the axis of interest. So from here, we can immediately state that Izz is equal to width, which is B, our depth, which is equal to what? Our depth is 2C cubed divided by what? 12. Okay. Now, coming back to our first moment of area, now we want to look at QZ is equal to A Y bar. Okay. Before we do anything, I like to highlight to you that Izz is a what? Is a constant. I repeat again, Izz is a what? Is a constant. And again, I like to highlight to you this, that Vy is also a what? Constant. Why is that so important? Y is varying, yes or no? Y can change. But our shear force and second moment of area, we have to take it as a what? Constant. Are we clear? If not, you'll be really, really confused. Okay. So we have derived rule number 1. Is that By and Izz are what? Constant. Okay, so whatever formula you put in later on, what is going to be constant is your By and your Izz. Okay. Qz is the confusing one. Okay. So now, Qz, we know, is going to be a function of Y. Okay. So when that's the case, remember I told you all is width. Okay, so the area width is equal to B, right? And the width and the depth is equal to what? The depth is equal to C minus Y And the y bar is c plus